All right, so continuing part 3. Okay, so the reason why I've been breaking down all these transformations so much is because as soon as you try to do more than one transformation at a time, your graphing can become really difficult. So there's an easy way to sort of categorize all of your information, and that's what I'm going to show you today. So if you you could graph your function by applying each transformation individually, but that would take a really long time. So instead we can sort of do it systematically, and I'll show you that right now. Okay, so here is an example of another function that I've just made up, some little graph. That little graph is called f of x right now. So this is f of x. So if we were asked to graph g of x, which is taking f of x, but is multiplying it by 3, and then we have not f of x, but f at negative 2x plus 8, and then the whole thing is being subtracted by 1, then we can see that there are a lot of transformations that need to happen. So in looking at this, we're trying to see, okay, well, what is each of these numbers doing? So this 3 at the front, that's our a value. That's going to be our vertical stretch. This negative 2, that's going to be our k value, which is our horizontal compression or stretch. This 8 is going to tell us about our d value, which is horizontal, but you can see that we have that scenario again where it needs to be factored out. So we know that this is c, and then we'll talk about d in a second once we factor it. So that's what you'd have to do first. This is like the next step. Okay, so if you see a coefficient on the x and no bracket separating them, and you also have a number that's being added or subtracted here, that means you have to factor it out. So it looks like this. So when you factor out that k value, you have your negative 2. You can see k is still negative 2. But now our d value we can see is negative 4 and not positive 8. So you had to factor that coefficient out of it in order to see that this is going to tell us about d. Okay, that's going to be our horizontal shift. Okay, so now we're going to take the same equation, we're going to listen to it, and we're going to apply all of its transformations on this next slide. Okay, so AKC, AKDC. The big thing there is factoring out the K. All right, so this is what the final graph is going to look like, just so you kind of have that reference. And I want to show you that first because we talked about what all these different transformations is going to look like, A, K, D, or C. So we'll break that down, and then we'll look to see if that looks like it has actually happened based on our descriptions. So we're going to list our transformations first. So the first thing that we're going to see here is this 3, which is a vertical stretch. And then this negative 2 is our horizontal compression. This 4 is our horizontal shift, and this 1 is our vertical shift. Okay, so they can be broken down into this, like into a chart form. So I know this looks pretty confusing, but bear with me one thing at a time. So here we have our table of values x and f of x, or in other words, x and y. So this negative 1 and 2, this is just, I'm reading the coordinates of the points that are in my function. So this black one is f of x. Here it's coordinates negative 1, 2, 0, 0, 1, 1, 2, 3, 3, 1. So those 5 points have just been listed right here in this table. Okay, so I'm just taking those directly from f of x. Now, what I've done here already prematurely for you is broken down what our transformations are going to look like. So we'll look at them individually. So number 1, we see a vertical stretch by a factor of 3. That's caused by this 3 right here. So that means that we're going to take our, since it's vertical, that's going to be something we apply to the y values. So this is our y values, anything vertical. Since it's a stretch, that means that we're going to multiply all of our y values by 3. Now the next thing in the list would be this negative 2, and that's a k value. So that means that it's something that's horizontal. So because it's negative, that makes it a reflection. That's our horizontal reflection right here. So that means that we're going to multiply all of our x values, since it's horizontal. All of our x values are in blue. We're going to multiply them or divide them by a negative to get that reflection. Now, because it's a 2, that also means that it's going to be a horizontal compression. So large number means compress for horizontal. So horizontal compression by a factor of 2. So this is how we kind of deal with that, is we take all of our x values and we divide them by k. Okay, this is what we're doing. We're dividing by k. Okay. All right. Okay, so then next is this -4 on the inside. That's also horizontal. We're going to move the whole thing right by 4 because of it. So it says -4, but actually it's going to move it all right. So again, that is a horizontal change, so I'm writing it in blue. And then lastly, we have this -1 on the end, which is vertical. It's a vertical shift down. So that means that all of our y values, because it's vertical, are going to be moved down. Okay, so one at a time for every single coordinate from our original function, we're going to apply these transformations. Okay, so here we have the x value is -1. We're going to divide it by -2. So that's going to make it positive, 0.5. And then we're going to do the same thing with all of our x values. So then this x value is going to be divided by -2, which is going to give us 0. This x value is going to be divided by -2, which is going to give us -0.5. This x value is going to be divided by -2. This x value is going to be divided by -2. Same thing. Okay, so right here, all I'm doing is dividing all my x values by -2. And that means I'm applying this horizontal reflection and compression at the same time. So the negative for the reflection and the 2 for the compression. Okay, so I'm just applying all of my transformations right there. Okay, next, the next horizontal change that's happening is we have this movement right by 4. So that I'm going to take all of my new x values and I'm going to add 4 to them to make them move right. So it's going to bring this one to 4.5, this one to 4, this one to 3.5, this one to 3, and this one to 2.5. Great. So now these are all my new x values. So let's get this in yellow. So in my new function, my transformed function, these are all the x values for all the coordinates I'm about to plot. So they were -1, 0, 1, 2, and 3. Now they're going to be 4.5, 4, 3.5, 3, and 2.5. Okay, so all those x values have all changed. Now we're going to talk about those y values. So we said that we're going to have a vertical stretch by factor 3, so that means we're going to take all of our y values and multiply them by 3, so that's what we're going to do now. So this was 2, it's now 6, that was 0, it's now 0, that was 1, it's now 3, this was 3, it's now 9, this was 1, it's now 3. So we just took all the y values and we multiplied them by 3. Now the next vertical change is to move the whole thing down, so we're going to apply that to the y's as well. So here are our y values, we're going to move each of them down by 1. So 6 becomes 5, 0 becomes -1, 3 becomes 2, 9 becomes 8, and 3 becomes 2. Okay, so now these are the new y values that correspond with my new x values. So basically these are my new coordinates. Now hopefully you can see, so this 4.5, its corresponding y value is 5. So at 4.5, 1, 2, 3, 4.5, I go up 1, 2, 3, 4, 5, and I have a new point right here. Okay, then my next point is 4, -1. So it was 0, 0. It's now 4, -1 after I applied all my transformations. So 4, -1 brings us down here. Okay, my next point was 1, 1. It's now 3.5, 2. So here's 3.5 and 2, which is right here. Awesome. Next, it was 2, 3. It's now 3, 8. So it was 2, 3. It's now 3, 8, which is up here. Okay, this next one is 2.52. So here's 2.5 and 2. Okay, so here are my new 5 points in yellow and red from my original function, which was in black. So hopefully, once you've done all of this work in your table of values, you should be able to look at your graph and see that the transformations you've described look like they've happened. So number one, does it look like our red one has been, is like the black one, but stretched by a factor of 3? Well, yeah, you can see like it looks as though someone has pulled it vertically, like it's a lot skinnier this way. Next, does it look like there's been a horizontal reflection? Well, that also looks like it's happened because you can see before the shape went down first, then up, and now it goes up first, then down. So we can see that it has been flipped from side to side. Okay, a flip from side to side has happened. We also said that there was going to be a horizontal compression by a factor of 2. So does it look like someone has pushed it on either side to make it more skinny? I would think so. It does look quite a bit skinnier than what we originally had. Which is in combination with the vertical stretch. Then we have a horizontal shift moved right by 4. So does it look like, is the red thing has it moved over by a bunch, by 4? So you can see that it isn't actually like 1 point doesn't move over by 4 individually, because there are lots of other changes that are happening. But in general, it's saying that the whole thing should be moving right in general, and it is definitely. That red function is more right than the black one. And then the vertical shift down 1, does it look like our function has been moved down by 1? It's hard to see because a lot of these points are actually above where they were, but the one that you can tell the most in is this origin. So this was 0, 0. And because it was 0, 0, any stretch or compression or horizontal or vertical flip did nothing to it. Okay, this one didn't change. It was 0, 0. It was 0, 0 here as well. The only time this origin changed, this point which was on the origin changed, was for a vertical shift or a horizontal shift. So from this point, do we have a horizontal shift over by 4 and down by 1? Well, yeah, we do. Okay, so once you've graphed your whole function, you should go through your list and see if your result makes sense. Because if your result doesn't look anything like what you described, then chances are you made a mistake somewhere. Okay, so this is that same slide I showed you before. I'm just reminding you. So if you have A, K, D, and C, so all these numbers that are embedded in your equation, then A is the number that you're going to use to multiply by your Y values. And K is the number that you're going to use to divide from all of your X values. D is the number you're going to add to all of your X values, opposite as you see it. So if it says minus, you're going to add. If it says add, you're going to minus. And then C is the vertical shift. That's the number that you're going to add to all of your Y values exactly as you see it. So if it says plus 5, then move up 5. Okay, so those are all your learning goals for today. So next is your homework, which I believe is box 8. And then we'll continue to bring this up tomorrow and have a quiz. Okay, thanks so much.